So what is an operating system? Well, the definition depends on who you ask, and also it has changed over the years. Several decades ago, computers used to be pretty bare bones. So typically there was just two levels in the computer hierarchy, so to speak. So for example, there was this hardware circuit which was supposed to execute the program, and then there was this binary program which the programmer intended to execute on the computer. So the computers were pretty simple, and the operating systems were also likewise pretty bare bones. However, over time, several layers were added and removed and merged in the computer level hierarchy, and therefore the computers evolved, and likewise operating systems evolved with them into a complex beasts. Essentially, there are two simple ways of defining the operating system. First, you can think of the operating system as an interface that sits between the user. So you can think of the user as user applications, your applications, and the hardware or the architecture of the machine. So that's one way. Another simple way of thinking about operating systems is think of this as a software which implements a virtual machine on top of the bare hardware, the actual hardware or the actual machine. And hopefully this virtual machine which the operating system provides on top of the actual hardware is much easier to program and work with as compared to the original raw hardware of the machine. So these are two simple ways of defining an operating system. Let's explore these further on the next slide. This picture over here illustrates the first definition of operating system. We said that an operating system is an interface between the user and the underlying machine architecture. So let's assume this is our true hardware of the machine, the actual machine, and these are the user applications. So these are the applications or processes, the programs that you want to run on your hardware. The operating system sits between the user application and the hardware, and it provides a more convenient interface of the underlying hardware, which makes it easier for the user or the user applications to use the underlying machine. A simple example would be, let's say you want to create a new file. So when you create a new file on your computer, you don't have to deal with the low level details. For example, where on the hard disk the file should be stored. You don't have to tell the operating system how large, not the operating system. Basically, you don't have to tell the underlying machine how large the file should be. Similarly, over time, would the file grow or shrink and so forth? None of these details you have to worry about upfront. The operating system takes care of managing the disk space for you. The file can grow and shrink over the time. Now you don't have to worry about the low level architecture details that are involved in those changes. This is a simple example of how the operating system hides the low level architectural details and makes it easier for users and user applications to use the underlying hardware or machine.